Test, test. Okay, so ready to go? Okay, so this talk is about my musical adventures for the last 4 years. First thing I'd like to say is that Burning Man is really cool, and I had a great time there. This is a picture of the dance pads. In the background there, you see this this plastic thing with my equipment in it, and then 8 dance pads there. So people would come and play around on them. I had them set up for three nights, and I have a little video here. That's me on the left. So that's what it looked like. Started going for 3 nights, about 2 hours a night, and got quite a few people coming up, and they seemed to figure it out pretty easily. There's another picture of me in a Burning Man. Clothing, you can pretty much wear anything you want to, although some people's sense of fashion can be questioned. So I'll be going over Keykit, the language, what its features are, and then going into a lot of depth on recent things I've been doing. So Keykit is a programming language. It's an interpreted language, very much like awk, except it has MIDI as a fundamental data type. So the whole point of the language is to write real-time MIDI algorithmic software. It has graphics, and all of the user interface of the GUI is written in the language itself, which has a lot of advantages. The reason I did it was just to have fun, and as a side effect, I learned a lot about device drivers and just lots of different things. It's not a commercial product, but it's packaged well enough that somebody can use it without doing any programming. It's gone through a number of revisions. It started out really crude, and everything was built in, written in C. About version 3, I completely rewrote it so that all of the new functionality could be added in the language itself, not in the C code. And that's been a huge win. Version 4 added graphics. I had an aborted attempt at multi-window stuff using OpenLook at the time. And then 6.0 I finally did a good multi-window interface. Made it a little object-oriented, mainly to support the window stuff. It's not great object-oriented stuff, but it's enough for small numbers of objects. And then recently I added support for multiple MIDI ports. It's been ported over the years to everything under the sun, including a sun. So the language is very much like awk. One of the big wins is associative arrays, which the values and the elements themselves can be of any type, including phrases, MIDI phrases, and function pointers, and things like that. So associative arrays become the data structure of choice in the language. As I said, one of the fundamental data types is a MIDI phrase. So here's an example of some constant MIDI phrases. A chord. The MIDI data type, you can use the structure-like manipulation to manipulate the attributes of of a note, so the pitch, duration, volume, and so on. This fundamental MIDI data type has all these different parameters or attributes. The operations like addition and subtraction have meanings which are intended to be convenient for manipulation of musical data or MIDI data. There's also a special operator called select, which lets you, it's essentially an implied loop around the notes of a phrase, and the end result only includes those notes for which that expression is true. So it's like a filter, and it lets you do things fairly concisely. The for loops, you can loop through the notes in a phrase quite easily. Function, one of the data types is a function pointer or reference, and so you can definitely take advantage of that and build fairly flexible code that's parameterized in terms of the functions. I won't go into the details that much. One of the unique aspects is the way variable arguments are handled. There's a number of different features for managing that. I'll show them here. If you use ... in an argument list, that essentially captures all of the arguments, however many are passed, and then you can pass that as a value in subsequent functions. So here you see an example of that. So the first two arguments here are function pointers, and the rest is whatever, and this is just calling either of those functions with whatever arguments were passed in. I use that to extreme advantage in the menu system. It's nested, and, so this has been a huge win. I mostly use the ... The variable arguments also have some functions that let you pack up all of those arguments as an array, and then you can call a function and unpack them. So I don't use this as much. The ... notation is the big win. So that's an overview of the basics of the language. It's multitasking. It's an interpreter, and it's multitasking. The tasks are interleaved at a very fine level, which means that real-time performance of any given task is never degraded by other tasks, or at least they're fairly degraded. And real-time I/O is never affected. So naturally, this is all because this is for a real-time application. MIDI input is always being recorded. I'll show examples of how that's used. All of the event things in the language, like MIDI, mouse events, console events, are read from FIFOs. A FIFO is there's functions in the language that manipulate FIFOs, and so all of these event streams appear as FIFOs. And so typically you spawn a task that'll be reading that FIFO, and then it does stuff with the input. There's locking, so you can synchronize. Since you have lots of tasks, you need to synchronize them some way. So as I said, the GUI, the graphical interface, is written entirely in the language itself, including the dragging of windows and resizing, and all the window manager functions in the language are implemented using the interpreted language itself. So here I'm bringing up, so this is Keykit running. I'll give you the basics of the GUI. There's pop-up menus, and you can drag them around with the little bar there, delete them with the X. And then if there's an arrow to the right, that's a nested menu. And if the menus have lots of entries, you can scroll in them. So these are the lists of all the algorithmic toys that that I've developed with this. One of the more interesting aspects of the GUI is that you can pull off buttons. I mean, you can pull off menus. I can pull off this menu and paste it there. So any menu anywhere in the system, even within a tool, I can pull off. But the most unique aspect is that you can pull off individual buttons. So if I'm going to be doing a lot of, the group tool is a sequencer. So if I'm going to be doing a lot of those, I can, rather than invoke the group item, I'm going to hold down the mouse and drag off to the right, and eventually it starts dragging the button. And now you can put the button down. And that button acts just like it would in the menu. So that feature can be used on any item anywhere in the system. I can pull off an individual button from deep within an application and put it anywhere on the screen. For editing things, that is a big win, because there are so many editing operations. You never know. At any given time, you'll be using a group of operations, and then at some other time, you'll be using another group. So it's hard to come up with pre-canned toolbars that are appropriate all the time. So this is a way that if you're doing a lot of something, you just pull them off on the fly, use them, and then you can delete them when you're done. There's some window manager aspects to the GUI. You can arrange windows. I can take these two windows and arrange them horizontally. I can resize this window to fill whatever space is available. So the interface tends to use lots of small windows, so it's useful to have ways of cleaning them up and organizing them. So I mentioned that it's always in record mode. So if I play something, let's go. Okay, let me take that last little bit. So here's. So then I can go in and clean this up, take these notes and delete them, take these other notes. Let's say I can, in this edit menu, there's all sorts of editing operations, so I can take all those notes and step them evenly for 16th notes. I can quantize the first note to start on a whole note. Some of the more algorithmic operations, I can fractal it, so every note in that phrase is now a copy of the phrase itself. You can shuffle them. Anyway, so there's just lots of algorithmic things, not really musically oriented per se, more structurally, just throw the notes around, and then when I'm using it, I use my ears to pick out the good pieces and build music out of that. So this is a screenshot showing a lot of the different tools. There's an ordinary sequencer. There's echo things. Some of these, because it's so easy to develop things, I program kind of in an improvisational way. So a year or two later, I often can't remember what the tool does. But some of the tools work out well, in particular some of the ones I'll show you, obviously. There's, over in the lower left there is a drum pattern editor that's very flexible. Okay, so the language designed for MIDI, there's lots of unique features of it that have turned out extremely well. For development, because it's an interpreted language, it's very robust, so when I'm doing development, I'm running stuff, playing with it. If there's an execution error, it won't crash the system or anything. It'll only crash the task in which it's running. So even an application which is spawning multiple tasks can be robust because an error in one task, that task goes away, but the rest of the application is still running. Okay, so some of the more recent things that have turned out well. Expresso is an application that manipulates music using L-Systems fractal generation. What that means is it starts with some simple thing, in this case just the expression X, and it applies transformations to that. I'll go to the next slide. These are the transformations, the default transformations. So if you start with X and you use that third transformation, you would change X into transpose X, comma 4. And then if you do another layer of transformation on top of that, you would take the X inside that transpose and apply another transformation to it. I'll show you the expressions that result from this. So I used this tool interactively at the Woodstock 2000 performance. It's turned out really well primarily because it generates a wide variety of things from very simple inputs. One of the challenges in algorithmic music is to write an algorithm that doesn't produce the same stuff all the time, or stuff that sounds the same all the time. So this tool is fairly unique in generating lots of different stuff. This is the GUI that you can use to interact with it. I'll show that in use. This is what my screen looked like at that Woodstock House and performance. There's 8 copies of that Expresso tool on the screen, along with some other things. And so during a 10-minute performance, I interacted with all these instances, generating new stuff on the fly and playing it. Let me demonstrate that. So here's the Expresso tool. By default, it limits the length and steps things, so it produces more sane sounding stuff. Okay, so here we're starting with a single note. That note under the Gen button, that's the note we're starting with, and it's applying that fractal transformation 15 times in a row. And down in the bottom here, I'll print out so what you see there is the horrendously huge expression that generated, all in terms of X. And so starting from that single note, what you see here is the result of that. if I like that result, one of the things you can do with these windows is every tool has a get and set operation. So I can copy the result from this window, say window copy from the Expresso tool over to the sequencer tool. So now I have it available in this sequencer, and I can zoom in on pieces and play them. So that's starting from a single note. So let's say I take that and I'll load that. And so that's an example of, it's constantly recording, so I just play whatever I want to and then I bring it into a tool. So a lot of the tools don't need any explicit, start recording now and grab stuff. They can grab stuff after it's been played, whenever it gets played. So now I'll run the same algorithm 15 times on those notes. Try another one here. I'll load what I just played there, which that's what I just played. And this is what results. I copied it over to the sequencer, and I'll zoom in. See what this sounds like. Okay, so this is the raw output. You can filter this. I can say auto apply scale all to last recorded. What this is going to do is generate that result and then map all of the notes to fit whatever notes I'm going to play right now. So I just played a triad, and I'm going to regenerate it, and now while it's playing that, I can play something else. Press the gen button. Now while it's playing back the old one, it's generating a new one. And now it's playing the new one. So what that shows is that the real-time stuff that was happening could be done in parallel with recording new stuff and doing a lot of computation, and then it starts the new phrase. So that's why it turned out well in an interactive performance. I could be doing all of this while the stuff is playing, and there were 8 of those going on. Okay, so I can make this a lot more interesting by not just generating one track, but generating up to 6. I'll generate 4. Gets more interesting if I turn on random patches. So now this is going to, for each of those 4 tracks, it's going to choose a random patch. Now that's, the starting X for that is a fairly nondescript phrase. If you took a little piece of Bach and did that, you would hear lots of samples of Bach throughout that. So a little more easy way of changing the patches, I can bring up this program change tool. So I'm going to start this playing and then randomly change the patches while it's going, rather than have to regenerate it to get new patches. Whoops, okay. So you can have lots of fun, and in the computer music world, people do whole pieces that sound like that. Okay, let's see. So that's Expresso. So that turned out really well, and I've used that algorithm as the basis of a number of tools, both interactively and also on my website. You can do that interactively. Another one that turned out well recently is called Typo. That's what I used at Woodstockhausen last year. Basically, I added to Keykit the ability to detect keyboard events, from the computer keyboard, both up. Am I cutting out? Okay, testing one. I can detect the keyboard events from the keyboard both down and up. And that includes the control key and the shift key. So after I added that, I was then able to write, code that turned the computer keyboard into a musical controller. And so I did that, and it lets you loop things. So I'll show you that now. Got to send it to the right synthesizer. So I played those first notes, and then I hit return, and then it starts looping them. I can play other notes along with that. It's not recording those until if I hold down the shift key, then it's recording them and adding them to the loop. That one got added to the loop. Pressing number keys, I can switch different sounds. Different sections. So that was one section. It's recorded that stuff. Now I've moved to a different section that has a drum beat associated with it, but different sounds. So the keyboard's fairly responsive, so you can play it. All of these notes are being quantized, they're being quantized, so it all sounds rhythmic. The big question is it velocity sensitive? Unfortunately, no. But if you ever hear of a computer keyboard that's velocity sensitive, I want to hear about it. Actually, it is interesting. You hear I played a chord there. Different keyboards have different, N key rollover, whatever that is, behavior. So there's some keyboards that have like a dead spot if I try to play multiple notes at the same time. So it's interesting keyboard-dependent behavior. But when you're doing individual notes, they're all the same. Recording a particular pattern, I can now go back to the previous ones. So I went back to some of the first couple patterns I did. So that one turned out pretty well. So the next one that's interesting, I call gene pool. You can call it, I don't know, genetic programming. It's pretty crude, but what I do is take sequences of notes and convert them into small opcodes. So you can, and the opcodes are at the level of increment the pitch, set the volume, increment the duration, and trigger the note. So if you consider that there's a state associated with this algorithm, and you have a sequence of opcodes, if you set the pitch to middle C, set the duration, and then trigger, that trigger adds one note to the result. If you then do another trigger, it'll add the same note, at the same point in time. If instead of doing another trigger, you increment the time and then trigger, you'll get a second note, a little later. So you've got these opcodes, and you can take any phrase and kind of decompile it, disassemble it into a sequence of these opcodes, and the algorithm here takes those sequences of opcodes and combines them. So if you take two phrases, take their opcodes, and there's a variety of different ways you can make them. You can take the first half of the opcodes from one of them and the second half from the other one. You can shuffle them. So I've only got some crude ways of mating them. You can imagine lots of different ways. So let me show what that looks like. So here's the GUI that can control that, you fill these cells with some initial phrases, and then you can listen to them, and if you don't like one of them, you do a right click, it will kill that cell, and then take all the remaining ones, take 2 of them randomly and mate them and produce a new one. Yeah?
So since it's all algorithmic, you can create selection pressure by having another algorithm that either kills some cells but doesn't like them or copies others and finds them successful in some way.
Right. You could currently the evaluation filter is your own ears, but you can definitely imagine something which has some criteria that it evaluates them on. So yeah, the problem with this stuff is that there's just so many things you can do. I tend to do dive into different things, fairly shallow depth, and then go on to the next. So here's, I'll bring up the gene pool. So I can fill these cells initially with either it'll generate opcodes randomly, or I can fill them from a file. So here I'll take some Bach stuff. So those are the snippets that are in these cells, and now I can take that one, kill it, and mate from the others. So that one probably pretty clearly is half of one of them and the second half of the other one. So everything's attached to the left and right mouse buttons, so I can very quickly audition them. You know, if I don't like it, immediately generate a new one very quickly. Let me try the random one. So this one's like starting from almost nothing, and you can kind of build up a particular kind of thing depending on, you control what the result is by your killing. Okay, so that one I like, so I'll leave that one. That one's okay. So if you keep going for a while, sometimes it works better than others. So I can turn on a mode where it'll just start playing and walking randomly around those cells. I can turn on a mode here where when I click in the cell, it'll print out the opcodes for that cell. So if I click on that cell, you can see down in the window here the list of opcodes for that cell. Okay, then the most recent thing is interfacing with these dance pads. I started seeing these, well, the dance pads, and I wanted to interface with them. And they make these PlayStation to USB interfaces. There's a dozen or so on the market, it seems like. And so I got some of them and started playing with them, and most of them turned out to be very non-robust. If you just unplugged the dance pad, you'd have to reboot the PC in order to get it to see it. But I finally discovered this one that works well, and the Windows device driver makes it look like a joystick, and the pads look like joystick buttons. And since it's USB, and this particular interface has two PlayStation ports, so with USB I've been able to plug in 4 of these interfaces and allowing me to plug in 8 pads simultaneously. And it's been surprisingly reliable, although I haven't had them in an arcade or something where people are doing it constantly. So I added support to Keykit using the standard Windows Multimedia API to get the events from these pads. It looks like a FIFO, so it can be manipulated with the same flexibility as any of the other input sources. One odd thing is that the device driver doesn't seem to put the pads in any particular order, so every time I plug it in, they're in a different order. So when I first start up, I have to press on the pads if I care about which one is which. And they're very responsive. I haven't timed it, but it's, in some of the algorithms I quantize the stuff, so you get some delay because of the quantizing. But I'd say it's on the order of 10 milliseconds, that ballpark. So this year what I did for Woodstockhausen was take these pads and do a piece called Happy Feet. It took a Bach piece and split into snippets and assigned them to the pads. And this is what you've been hearing at the Beer Bash a couple times. So these dance pads, there's eight main buttons. The center is not active. So you got 8 big buttons you can play with, and those control those play notes. And then there's a select and start button at the top. So I use those to enable control functions. So for example, hitting select and then the up arrow will transpose everything up an octave. Select down an octave, and so on. This diagram shows the controls. So the upper left grid is when you hit select and then one of those pads, that's what the operation is. If you hit select twice and then a pad, that's what the lower left grid shows. So when letting other people play with this, especially at Woodstockhausen, or not, at Burning Man, people would start playing with the select and start buttons and invoking all sorts of random things. So I think I need to have a mode where those functions are more hidden so that people can't accidentally trigger them. Let's see.
The next composer is a longtime Woodstockhausen alumni. I would like to introduce Tim Thompson and his performance Happy Feet.
I had this electroluminescent wire attached to my pants, and you can just barely make it out. See the outline of my pants. So all you could see on stage was my pants. That's it. So you could tell in that piece that there were a lot of phrases from the Bach piece that you could recognize.
So you said it was always recording, so even when your stuff that you're playing, like in Expresso, is recording those still?
The question is it always recording things it's generating as well as what you're inputting? So by default, it's always recording what's coming in from the external input, the external MIDI. By default, it's always recording that. You can, but it's not recording what it's generating itself. So if Keykit plays something, that's not recorded. But you can turn on a mode where it does record everything that it's generating. And so that's really important. If you have, like when I had those 8 Expresso tools, and let's say I wanted to record that performance in MIDI, I could turn on that mode where it records everything that's being generated, and now all 8 tools, all of their output would be recorded. Any other questions? Oh, that was one of the better, I mean, Burning Man, I could go on for hours about what I saw there. This was just out in the middle of this huge playa, as you can see. That's a solar-powered amp, and then on the guitar is a two solar-powered motors, and they have rotating picks on them. So this is a self-playing guitar out in the middle of the playa, and by putting your hand over the solar cells, you could control, how fast it's picking. I heard later other people were more adventurous and were playing around with the tuning on the guitar. And I sent mail to the guy who did this, and he said next year he's going to have a bass guitar in addition. Although it's somewhat hard to find out who does these things at Burning Man. There's just dozens and dozens of things out in the playa, and there is no label or done by. So a lot of times you only find out by being there when the person is setting it up, or in this case I heard the guy on a mailing list talk about it. One of the other good ones was a laser harp, a cube, like with four walls, and on each wall there were maybe 20 or so lasers going down, and if you interrupted the laser, it would sound a note. So it had sensors, and it was all MIDI stuff. And so you would be playing by just waving your hand in front of these laser things. There was another thing called the Aural Reef, which was a big room with all sorts of algorithmic music things inside, controlled by all sorts of things. No dance pads, but similar kind of different kinds of controllers. Oh yeah. On my website, you'll see some pictures. There's one of a structure with take an oil drum, split it in half vertically, and so those become the things that catch the wind. And then below it, they had a bunch of bells, and on the rotating thing, it had some bars. So as the top thing turned, it would strike the bells. And then they had a bar there that you could play it yourself. So as I came up to that one, this woman was actually performing a piece, just by herself on the bells. So after she finished, I gave her a hand, But the place is so huge, it's really incredible. There's, I'm sure there were quite a few more wind-oriented pieces. And I kept hearing about things that I never saw, like a harp with 19-foot strings that would somehow be played by the wind. I never saw that one. So the place is just so huge, it's impossible to see everything.
So this stuff is cross-platform, and will run on different.
Yeah, it'll run. Well, it'll run on Linux. The MIDI and audio libraries on Linux are under constant development. So, but it will run with the Dev MIDI device on Linux. There's some TCP/IP support. I haven't actually mentioned that I've done some network experimentation. So, doing jamming between two people over the internet, where each side is synchronized, to their own clock, but resynchronized to the other side. In other words, if you have a 4-beat pattern, and I'm jamming on my side, my stuff is being sent to the other side, and then being played in synchronization with his 4-beat pattern. So there's TCP/IP hooks, and those hooks work on Windows and on the Linux one. So I actually use Keykit on my Linux box kind of as a proxy to send the stuff in between. It also runs on the Macintosh, but just barely. I've never owned a Mac, so I've never been able to work on the port. But
Does it require fast internet, or can that be done on
MIDI is extremely compact, so this kind of real-time stuff is very easy to do over the internet, assuming you're willing to live with some latency. In other words, perfect synchronization, is almost impossible, so I don't even try to do that. But synchronization within a beat or two is pretty easy, and the MIDI, and I actually don't even send MIDI over the wire. I send the textual Keykit constants over the wire, which is almost as compact. So musical data with MIDI is unbelievably compact. Oh yeah, if you go to nosuch.com, you'll find it. So this summarizes the availability. The complete source code is available. Yeah, and there's a mailing list. There's it's hovered at like 3,000 people on the mailing list for years. They're not real active, at least visibly active. A lot of times I'll hear from people who have developed things and I've never heard from them, but they've been developing and using it. So there's one, the most innovative use by somebody else it's a system called GeoMaestro. It's a graphical thing. I mean, he just did amazing stuff. You can imagine putting circles on the screen and points along the circles, and then projecting from those points onto, let's say, a line. Okay, so you're doing a projection. Every one of those points represents a musical event, and you get your projection, and the timing along that line the spacing on that line determines the timing. So if I showed a picture, it would be more obvious. But he's built an incredible system out of that. Oh yeah, Windows, it works phenomenally on all Windows systems. Yeah, and real-time performance is good, and because it's super fast in the phrase processing, largely because I developed it back in the days of 8 megahertz, 20 megahertz, 286s. So I had to optimize the phrase processing, to make it possible to write everything in this interpreted language. So now it just screams, which just means I can build larger things. So those, the Expresso things were processing, tens of thousands of notes in very little time.
Are you aware of other such toolkits?
The question is, are there other such toolkits? There's a system called Max, which is more of a graphical system. You program by placing blocks on the screen and connecting them. Except for that difference, which to me is huge, but except for that difference, it's very similar in terms of flexibility. And in fact, that system does MIDI and it also does audio. So Max is definitely the commercial system that's quite close, as long as you're willing to do your programming graphically. The Cakewalk system that's been around for a long time has a Lisp style language that's built into it. That's another one that's similar. But for just ordinary, C-like programming, there's no language that's like this for people who just want to do kind of ordinary functional programming. That's it. Okay, thanks.